So hello, ladies and gentlemen. It's a pleasure to be here. So if anybody is still enjoying coffee there, please come to the venue because at the end of the lecture there will be an exam, and if you're missing the first slides, then it's most probably a fail. Just kidding. No exams today. So today I'm giving you a brief overview about this kind of like information model-based processes in public sector. Firstly, focusing mostly on the permitting for the building permits, and also covering a little bit about the urban planning as well. So a little bit about me. I'm Chris. I come from Estonia. So at the moment, I'm the head of digital construction in the City of Tallinn. Also doing my PhD in the Tallinn University of Technology. Also collaborating a lot with the different organizations throughout Europe. So for example, I'm the steering committee member in the EU BIM task group, and also have been several years a member in European Network for Digital Building Permits. And before joining Tallinn, I was several years working for the Estonian Ministry of Economic Affairs and Communications, where I was developing this BIM-based building permit system for Estonia. So I actually know what I'm talking about here. About Estonia, how we like to introduce ourselves, like Estonia, we have the digital society. I think this is like the key background moment that you need for these kind of e-services. You need e-identity, you need e-signature. So for example, if I have to put my signature somewhere by hand, I sometimes have to practice it several times because for me the signature is a 5-digit code that I put in logging in online. Like a year ago or so, when I was having the presentations, I could say like there are still two services like where you have to be there in person. What you can't do digital is like if you want to get married and if you want to get divorced. But now apparently we have digitalized that as well, so I don't have any good examples to make for you. But so to look, where is really the problem in our industry? We're talking much about this kind of lack of digitalization, but digitalization alone is not the answer. Because if we have a chaos and we digitalize it, what do we get? We just get digitalized chaos. So basically the problem is the information flow throughout the building life cycle. And actually we have to think about the building life cycle from the urban planning, like the master plans, the detailed zoning plans. Then we go to the construction design, etc. But if we have just these kind of like digital workflows, but they are fragmented, then it's not the solution. We have to address these information gaps. And of course, somewhere there, let's see if the laser works on the screen, no. We have the building permits, we have the detailed zoning planning, etc. And how do we actually address these things? For example, in the City of Tallinn, we call this process TalBIM. So we start from the detailed planning. We use already some kind of like information models to this. Then when we go to the construction design level, then after this kind of like conceptual design for our own buildings, we demand that these buildings get the BIM-based permit. But these kind of buildings that are in the City of Tallinn but are not owned by the municipality, we cannot make this kind of like compulsory thing. So it's like if you want to use it, then you can use it. And of course, there are like the city's digital twin in place where we transfer that information, what we use for the facility management, etc., etc. But if we go to the central government, like what is this kind of like role of the government? How can the government, the central government, really address this problem, address these information gaps? Of course, there are these three traditional pillars like education, the legislation, the process improvement. But there is another solution. So for example, in Estonia, we created this kind of like digital platform, what we call e-construction platform for this kind of like better information flow. So what really is this e-construction platform is the idea and this kind of like mission that we have to transfer the data. And we have to exchange it so it would be lossless, and the data itself, it needs to be standardized. And who has to benefit? All the stakeholders in the process. So, but what really is the construction platform behind that wonderful idea? It's basically, I will explain it through these kind of like examples where we have the data layer, we have the service layer, and we have the user interface layer. So for example, the central core of the construction platform is the building registry, where we have like the data about the buildings and also the procedural environment of the building permitting. Then we also have the data about underground structures. Now we are also putting that into the 3D. Then we have these kind of like BIM services like BIM-based permitting. Then we have entire national digital twin that we can address that information, we can access it. And there are like a lot of different databases that are connected it. We call it the X-road connection, so that the data is always with its source, and it has to be like that. And then we are addressing also getting some information from the different fields, like from the Ministry of Finance, who is responsible for the spatial planning. We're also getting these kind of services onto the construction platform, and we're also opening the platform up for the private sector services, which are very good services, but they don't make sense to fund them from the taxpayers' money because they are beneficial for the selected few. So it makes sense that if some company wants to monetize the service, they can use the e-construction platform to do it. So what this e-construction platform really is, it is this kind of like umbrella of the different services which has this kind of like common architecture, language and philosophy, and of course the style guide as well. But now closer to the topic, when we're talking about permits, we have this kind of like e-permitting system already in place from 2016. We call it building registry, but in international way, it is mostly like building logbook that we are talking about. And in this building registry, we also have this kind of like procedural environment, so that you can get the building permits, and because we have the data, then we can address this, access this data, and also we have this information portal when you can get all of the statistics about these buildings. So how does it really work? If you want to get the building permit, you just address the building registry. Then the local municipality who has to process the permit gets this kind of like notification. They will start the process there. They will also add this kind of like tasks to the utility network owners, to the rescue board and other state agencies. They give their remarks within this environment. Then also local municipality gives their remarks, and if everything is finally correct, you just get your building permit. But about these building permits, why do we need them? It's like, yes, of course, to ensure the safety, legality, and the efficient resource. But then also it is a key process in the building life cycle, because this is this kind of like obligatory thing you have to do. It's not that you wake up in the morning and thinking like, what a wonderful day, what do I really want to do today? How about one building permit? Nobody thinks like that, of course. This is something you just have to have. But at the moment, the process is quite expensive, it's time consuming, and if you want to solve it, usually it's like more manpower, more money to enforce it with this kind of like brute force. But there is a better way. And what is this better way? Is this kind of like BIM-based building permit process. We started with it already in 2019. We did this kind of like first proof of concept level. Then we developed the software with our partners, of course. We didn't have the in-house IT development team, so it all went through the procurement. And from 2024, it's live. So the first building permits are BIM-based already in process. And there are like these 4 key elements: the transparency, the speed, the quality, and simplicity. This is what we want to address with this kind of like BIM-based permitting. And of course, there is this kind of like automated rule checking and these kind of things behind it. And we are only using the open standards, the open BIM, only the IFC. So no Revit, no ArchiCAD, no proprietary formats. And this initiation was also acknowledged by the Building Smart International, who gave Future Insight, who was our development partner, the award for the most promising technical solution in 2022. But when we want to get the BIM-based permit, we talk about this kind of like automated rule checking. We also need this kind of like common BIM requirements, because otherwise we cannot do this kind of like automated rule checking if the data in one model is different than in another model. So we need this common language. And for this, we have these user-defined property sets. At the moment, they are still in the Excel format, but we are in the process of implementing them to the IDS, the Information Delivery Specification Standard, so they would also be machine-readable. And there are like different parts. We have also integrated them together with the IFC standard so that nevertheless they are in Estonian. They also have this IFC property sets and the references. And this is how we can actually implement these kind of things, that if you want to get the BIM-based permit, you have to have your data according to these requirements. If you want to use different kind of requirements, go ahead, but then you can't have this BIM-based permit and you have to go for the traditional solution. So, about the lessons learned, what did we really learn about this process? That you really need to get this kind of like right checks to start with. Because when we started, we wanted to automate about 70 checks, and we ended up with 47 because some of them did not make that much sense of the benefits, and also some of them were just too complicated to solve by technological means. Also, these kind of BIM requirements, if you are doing them, they have to be very simple, they have to be clear. You always have to consider there are like two sides. There are like the designers, and then there are these kind of like permit processors, and if you're just pushing the data to the designer side, then all the time that you're saving from the process side is being used up in the designer side, but there is this mutual time. You have to find the balance so it would be as easy as possible. And of course, when configuring these checks, you have to have the multidisciplinary team. You have to have the architects, engineers know what you're doing. You have to have the building permit processor to really give this kind of like insight what they are controlling in the rule compliance. And also the lawyers and the IT specialists so that all the rules are correctly interpreted. And of course, you have to keep this kind of like agile working process. But there are still some challenges that you just can't escape. Software. So when we're talking about the IFC, I hope I'm not too harsh on that, but still, IFC is basically like democracy. It's not perfect, but it's the best that we have right now. But still, it's the export of something. You're not doing your design in IFC. You're still doing it in Revit or in ArchiCAD, and you're exporting it to the IFC. And when you're thinking like, okay, IFC schema enables it, some softwares are still not capable of putting all that information that is according to the schema to the IFC export. Then the BIM requirements, if you're having them, and then you need to do some new checks, and you're seeing like, okay, but for that check, I need some additional attributes. Then you have to add these attributes as well to the BIM requirements, and you have to do it in the agile way, because if you think of like all the data that you might need someday and you start demanding it right now already, then you're just creating the data that you don't know why you need it, who needs it, when they need it. So it has to be according to the level of information needs standard as well. And also the legislation, if you want to automate the checks according to the legislation, this kind of like thing, there are like a lot of talk about this legislation has to be machine readable. But first of all, you have to make the legislation human readable, so it's really understandable. It's like basically when I, as an engineer, I'm reading some of these things, I'm like, okay, but how do I measure it? Even if I don't understand it, then it is impossible to put it to the computer to understand it. And if there is like infinite amount of interpretations of this clause, then this is what happens. At the end of the day, there are like two lawyers arguing in court. Is it like this or like that? And the engineers don't have anything to say. But of course, the biggest challenge of them all is implementation of all this process, because it needs a lot of change. And the change needs also management. And like in every organization, there should also be a change manager, but then you are working in your organization, so I would like to see some hands, like who has the change manager in their organization? Okay, no exceptions. Like the fourth or fifth time I'm asking this question, I see no hands. And this is very important. You really need this kind of like change to go to another site, to develop what is there, to see what is there, and don't be afraid to do it. And how can you do it? And the best way to do it is, of course, the collaboration. And for the collaboration, it's also important to do it on the international level, so don't reinvent the wheel. And very good opportunities for that, of course, is the EU BIM task group. I know that the Croatia is already part there. You are very active there. This is one of these kind of like places you can do it. You can exchange the knowledge and so. And the other part is the European Network for Digital Building Permits. And if you take a quick picture and to go to the site later on, we had this conference in Barcelona in April. There are like a lot of materials, a lot of different articles about BIM permitting, e-permitting, etc. So go ahead and just look about it. Here's a quick video, like how does this kind of like BIM permitting really looks like. Then we have a model, and this just this kind of like in this example, it's a 5-story building. And all this kind of background you see there, this is taken from our national digital twin. So architects are only giving this 5-story building, and because it is geo-referenced, we get the background already from our existing data, so you don't need to recreate the data and duplicate the data. About the automated checking, here very simple example of this kind of like area check. Every working room, living room, and bedroom have to have the area of at least 8 square meters, which comes from the law, for the housing, for the apartment buildings and single houses. And if we have this data in the building, we can very easily check it. We can see, are there any red results, are there green results? Of course, with the green, if you see everything green, there is always this case, there might be something false positive. And this is much more dangerous than false negative examples, because false negative is like red. You see it red, and you think, okay, it shouldn't be red, so at least you can see it. But with false positives, it's always a dangerous road, and there is no 100% solution for that. And the other example, it's in the white background. It's actually a school building. And because it didn't have the geo-reference, no background is coming to the model. So in the later stage, we will stop adding these kind of things. So at the moment, it is a possibility. You just don't see the background. But we didn't want to close it down permanently. So if somebody uploads their model without the geo-reference, they can still do the checks and see the results. Here is another example of the check we're checking, like if the apartment is situated on the 4th floor or higher from the entrance, it has to have the access via the elevator. So we have to have a lot of data in that model. We have to know where is the elevator, also where are the models. So here, another example about the fire safety. It's like, do all the structural parts of the building have this kind of like fire safety requirement, the REI code according to the needs? We see there are some red elements. Actually, they are false negative, but the fire safety specialist can quite easily see the solution. So it's not of that big deal. And also, we have quite many fire safety checks implemented there. One thing also would be this kind of like escaping routes. So if this kind of like escape route is 30 meters or less, or 45 meters or less, and this is this kind of like check that the fire safety department usually just has to measure from the BDFs. And when they get this information from the model, it's just helping them so much more. But from that video, I now switch my talk from the BIM permitting to the urban planning. So when we're really planning something in the city scale, we really have to ask, what is the purpose? Of course, the purpose is to create this kind of like best place to live in and desired destination to arrive to, so what we call it, the best urban environment. And like here, you can see, like if you see the renderings of some kind of projects, what is similar? Summer, very nice. But sometimes it's winter, it's not that nice. We have to consider the climate. And right now, it's like at the moment it's still light, but end of or middle of November, it's quite gray, it's quite dark. So when we're really planning the urban environment, we have to consider also what's happening most of the year, not only considering the summer when everything is really nice. Okay, let's render these nice pink blossom Japanese cherry trees because it looks exquisite. But yeah, it gives this kind of like false impression. So, still the best environment is the purpose. And what is the starting point with the urban planning? We have this kind of like 2D drawings, 50 plus pages of explanatory letters. The process length is not good, it's very long. The formats are not machine readable. And the participation by this, like there are like people who can come and express their opinion about like, do I like something that is planned here or so? And you have to understand these kind of drawings. It's not user-friendly, I would say it's user-hostile participation. But is this really how can we create this kind of like best possible urban environment? Of course not. And when you look at this kind of like drawing, then 25% in the left side corner is what is planned there, and 75% of that is how can you read this bloody drawing? Well, this does not make sense. And this is not how we can go forward. But how can we do it? Well, spatial planning information model. We will call it BIM-based planning, but BIM is for the construction. But because this is not this kind of like term that everybody knows, BIM is like, yeah, I know BIM, I do BIM. It's like, for some BIM is 3D, but still they know what is BIM. But when I'm talking like, okay, let's have the same thing in the urban planning, then it gets more complicated. We really have to define what is this kind of thing. And then we started piloting in the city. So before you saw the drawing, now this is the same area. This is what we are actually planning there. We have the architectural sketch there, we have the volumes, we have the new trees that are going to be there, some kind of like greenery layers, etc. And then we broadened the scope so that like Tallinn Harbor area, there are several detailed zoning plans at the moment in the process. And how can we really see this kind of like environment existing and the future environment, 3 dimensions plus the data, and because there is the data, we can do the analysis already, the insulation, like how much sunlight these kind of buildings will get, what is the noise impact on these buildings, what is the wind impact on these buildings, and because of these things, we can make these decisions so early that have quite crucial impact on the process, because at this stage, the price for these decisions is so much smaller than it is later in the project stage. And of course, about the automated rule checking, I will show it in the video, how it actually looks like, because again, we did this kind of like proof of concept. So again, we are in the Tallinn City Harbor area. Then for the background, we can just switch on and off our existing models that come from the national twin. And then we have their different WMS, WFS services, for example, the points of interest. Then we can have all the restrictions that come from the utility networks. Then again, we can have like this kind of situation, what's happening regarding the sea rise level, how can the situation be with the flooding, and all these kind of services. And now we want to implement the information models from the planning. So there are like 3 examples in this proof of concept. The different detailed zoning plans that are in the process. And with these kind of things, even visually, without the automation, we can see this kind of like cohesion, like how these areas are interacting with each other much better than just comparing layer on top of layer PDFs that you zoom in, your computer starts lagging, you go and get a cup of coffee, come back and you see, okay, I still have to do restart and start from the beginning. And with these kind of like models, we also did the different automated rule checkings, 7 of them actually, to get this information quicker so you don't have to search for that information and you see the quality of your design. So first of all, this kind of like a simple area check. So like how much the transportation area, how much buildable area, how much greenery, where is the gap. We see there is a huge see that there is a gap in the drawing. And also the overlappings, because sometimes the layers are on top of each other. And if we are creating this model and these layers are on top of each other, we can get this overlap information. Then again, the greenery requirements, that if by the master plan at least 20% of greenery of every plot in the detailed zoning plan is required, we can get this information very quickly. Is this greenery provided or not? Also, the buildable areas heights. From the master plan, it comes as 23 meters for this area, and we can see that there are like 2 buildable areas for 20 meters and 1 for 17, 1 for 3, so everything is okay. Then another check would be the distance of the buildings or buildable area from existing buildings or planned buildings. At the moment we are having this 8-meter distance, so of course you can go nearer, but then you have these fire safety requirements that you have to consider, and if you have the space, then you can already do it without considering them, because it takes some money. And here there is a distance from some kind of point of interest. Here we took the fire hydrant, but you can have whatever point of interest, distance from the bus stop, distance from the school, distance from the kindergarten. And here is an example of the conflict area. At the moment, one buildable area is touching the railway protection zone. Of course, in the real life, we don't have the railway there. We just inserted it so that we can showcase these kind of things. And by the naked eye, you wouldn't see this kind of like conflict, but because it actually happens, you can see that you can't have your buildable area there. But again, you can have these conflicts with the heritage protection areas, the flooding areas, which are not errors but warnings. They're warning you, yes, you can build there, but maybe in 50 years your house is below the water. Or yes, you can build there, but because of the heritage protection requirements, it's going to cost you 3 times more. If you shift your building a little bit out there, it's not anymore in the area. And here also the buildable area distance from the cadastral border, so that most of the municipalities in Estonia, they have these requirements that you have to have at least 4 meters from the border. There we can see that, for example, one building was stretching the plot and 2 buildings didn't even have the plot around them. So you can get this kind of like quality information quite quickly that you might miss as this kind of like just doing it as the human checks, the manual checks, because the manual checks, they are error prone. And if you discover something already when there have been like several years of this process, then they need to change it. And it's, again, they say time is money, but actually it's not true, because you can always print more money. European Union is doing it, USA is doing it, everybody's doing it. But I haven't seen the time printer yet, so time is more valuable than money. And with that note, thank you very much, or as you say, hlava.